let me show you some of the linear algebra that you actually use when you're doing machine learning or AI. I have here a model that I fit in R, and just like typical notebook, data scientists would look at the data visualization, bar charts, to see the distributions and so forth. That's cool. So this is like what data scientists do all the time. They do this sort of notebook analysis. But what if we wanted to look at a step lower and kind of peel back 0 or 1? And I'm going to use what's called SciLab, which is a mathematical program that's basically really just for linear algebra. And it's used to, so in this case, when I look at the data, it doesn't even have any column names. It's just look at like the sum of x. It's just adding up all the numbers. Now, like a matrix is just an array of numbers. So you could do like x plus 2, and it just adds 2 to every value in this matrix. Or you can do x times 1 million, whatever. And obviously we just multiply all these numbers times a million. But what if we want to take a machine learning model in SciLab? How would you do that? So you first have to fit a Gaussian GLM via normal equations. You solve for beta hat, which is x transpose times x to the inverse times x transpose y. This direct inverse approach is fine for demonstration, but for numerical stability, alternatives like QR decomposition is recommended. For moderate data sizes, normal equations are typically acceptable. So like x transpose is right there. That's where you just take your matrix and you flip it 90 degrees. And then you have to take the inverse of x transpose times x right there, etc., etc. And then you compute the beta estimates. So the SciLab, there you can see it's predicting these numbers. If you look at the numbers that you get out of R, this is exactly the same numbers. So then, yeah, you can look at all this stuff. Like you can look at the standard error of the standard error right there is the same as what you see when you look at the summary of R. And then the t-statistic is assuming that the standard error follows a t-distribution. This is like a symmetric type of distribution that has wider tails than a normal distribution, and that means it's really important. Yeah, so all of this is basically saying that the algorithms, the machine learning code that you're running is very basic, just running matrices being multiplied together. And if you look at like ChatGPT, I was using the O1 model, which is a really powerful tool that